Okay, today's October 3rd, 2011. We're going to do the example on page 78 and 79. We're on lesson 2.2. We're finding volume of composite objects. Again, composite objects are objects that are made up of many different shapes. So we did some of this stuff yesterday where we did area of composite objects. Today we get a little more in-depth with this stuff. Okay, so they've given us this object. The height of the rectangular part of the building is 202 centimeters. The base of that same building is 310 centimeters. And the depth, or sometimes known as, sometimes it's known as the height, but we're going to call it the depth in this case, of the building is 289.5 centimeters. And then the roof, height of the triangular roof is 79 centimeters long. Now, the question is asking us to answer in cubic meters, okay? There are two ways we could do this. First, we can go about our normal conversion rate. 1 meter is equal to 100 centimeters. So we could convert everything back to meters if we liked, and in which case we'd have to divide all of these by 100. Okay? Or what we could do is we can solve these all in centimeters and convert at the end, except the conversion rate will be different. I want you to think of it like this. 1 meter cubed, okay, the same idea, is equal to 100 centimeters cubed. Now remember, our exponent rule is we bring the cubed inside, and what's going to end up happening, 1 cubed is equal to 100 cubed. What is 1 cubed? What's 1 times 1 times 1? Just 1. 100 cubed is different. Bring up the calculator. 100 to the power of 3 gives us, is that a million? Yeah, that's a million. So, what that means is 1 meter cubed is equal to 1 million centimeters cubed, okay? Imagine we keep the cubed on the outside. So you have your two conversion rates. You can either convert at the beginning, everything into meters, or you can convert at the end, which is a different conversion rate because we're working with volume. Make sure you know the difference. Don't convert at the end using this one. If you're going to convert at the end when everything's cubed, make sure you use this conversion rate. 1 meter cubed is a million centimeters cubed. Okay? Okay, so we have our shape again. The first way I'm going to solve this is I'm going to do it all in centimeters, okay? Because I've showed you how to convert from the beginning before. Today I'm going to show you how to do the conversions at the end. So we're going to keep this in centimeters. And what I'm going to do is I'm going to break these into two different shapes that have 3 dimensions. So, we know our first shape is this rectangular prism, okay? So it has height, up and down, width, and depth. That means it has 3 dimensions. And the other shape we're going to break this into is a triangular prism. Okay? This triangular prism has height. It also has the exact same base as our rectangular prism and the same depth. Okay? So I'm going to redraw these two shapes. Pause that. So I've broken these into 2 different shapes. We have our triangular prism and we have our rectangular prism. Okay? First of all, these both have different formulas to solve. Whenever we're doing volume, one way to look at it is to find the area of the face of the object and then to multiply by the depth. So when I talk about depth, I mean that face constantly multiplied. So this is our depth in both instances, how far back it goes. Our face is the triangle, hence why we call it triangular prism. And our other face is the rectangle, hence why we call it rectangular prism. So we're going to find the areas of these faces and then multiply by the depth. So we had our measurements. Remember, the base of our rectangular prism was 310. The height was 202. And the depth was 289.5. And these are all centimeters. Now, because the roof was on top of the building, it had the exact same base, like we said before. The base of this triangle is the same base as our rectangle. So the base of this object is 310 centimeters. The height of the middle of the triangle we had was 79. And the depth was 289.5. The exact same depth as the rectangular prism. Now, these both have different formulas to solve. What I want you to do is think of the formulas as the volume is equal to the area of the face times the depth. So we'll start off with the easier one. The volume of the rectangular and the triangular prism. The volume of the rectangular prism. The area of the face is just height times base, right? So we do our height of our object. We'll call that our h. Times the base of our object. And like I said, we multiply by the depth. This is the depth of our object. So really, our volume is just our height times our base times our depth. That's the very first type of volume we ever learned when we were going through math. The volume of the rectangular prism is a little different. We have to find the area of its face. So remember, the area of a triangle will be 1/2 times the base, which is here. This is our base, times the height. This is our height. And then I said again, we got to multiply by the depth. So we just add d in at the end. So we have our two formulas. The only difference between the triangle and the rectangle volume is that we have multiplied by 1/2. Okay? And one way to think of that is a triangle is half of a rectangle. That's why we have the half in the formula. Otherwise, these formulas almost look identical. HBD, happy birthday to both of you, and then multiplied by 1/2. I did it for you, Sampras. Okay, so let's plug in these numbers. We'll deal with the volume of the rectangular prism first. So our height, 202. Our base was 310. And our depth was 289.5. You can do that all in one step on the calculator. So 202 times 310 times 289.5. Oh man, I can barely read that. 18,128,000. 18,128,000 and 490. What is the unit measurement? Centimeters cubed. So this is centimeters cubed. And remember, with our conversion, sorry, that's on the other page. With our conversion rate, that probably makes a bit more sense now. Okay? It looked like a lot. 1 meter cubed. What happened there? There you go. 1 meter cubed is equal to 1,000,000 centimeters cubed. That makes more sense now that we have such a large number. Okay? So we found the volume of the rectangular prism. Next, we're going to work on the triangular prism. So we have 1/2 times those exact same numbers. Oh, sorry, except for the height. My fault. The height is 79, not 202. Oh, I'm plugging it in for the wrong number. We started with base. Our base was 310. Our height was 79, and our depth was 289.5. Okay? Now remember, 1/2 is the same as 0.5 on a calculator. We would just take 1 divided by 2, 0.5. So we do 0.5 times 310 times 79 times 289.5 equals. And we end up with 3,544,927.5. 927.5. And again, this is in centimeters cubed. So we found the volume of the top of this object and the bottom. Well, we want the volume, obviously, of the entire object. So what we're going to need to do is we need to put these two together. The total volume, so volume of total, will be equal to the volume of our triangle, our triangular prism, plus the volume of our rectangular prism. So we're going to put those two numbers together. Our triangular prisms was 3,544,927.5 plus 18,128,490. Can you do that in your head for me, please, Nicholas? Good. Someone read it to me. 21 million. 673,000. What was the last part? 0.5? Sorry, 17. Centimeters cubed. Okay, so we've solved this in centimeters cubed. And like I said, this time, instead of converting at the beginning, we decided we're going to convert at the end. So let's go back to our conversion rates. If you guys remember them, we're working in centimeters cubed. So 1 meter cubed is equal to 1,000,000 centimeters cubed. Okay? So we're going to set that up as a ratio like I've shown you before. We knew that 1 meter cubed is equal to 1,000,000 centimeters. Okay? And let's change that sign there. We're trying to find our meters cubed. That would be our x. And our measurement is 21,673,417.5. So we're trying to solve for the x. This is our meters cubed. This was our, we know that was 1 cubed, and these were centimeters cubed. This is our measurement cubed, and we're trying to find x meters cubed. Okay? So I can get rid of all those unit measurements and just leave these as terms. 1 divided by 1,000,000 is equal to x divided by 21,673,417.5. Okay? So, first thing I'm going to do is, 1 divided by 1,000,000. I'm going to solve for the left side of this equation. So, 1 divided by 1 followed by 6 zeros. We get 0 point, and there are 5 zeros. 1. And that is equal to 21,673,417.5. Okay? All I did was I took 1 and divided by 1,000,000. And we got 0.000001. Next, I got to bring over our 21 million. Okay? Same rules as before. So we have 0.000001 times 21,672,417.5 will be equal to our x. Whoa, I don't know why I put m. M. So we multiply those numbers. We have it up there times 21,673,417.5 equals 21.67. Essentially, all it did was move the decimal over 5 units. So we get 21.67. And you're going to get the rest of those numbers, but I'm okay with 2 decimal places. So what that found, we got to make sense of this. And we go all the way back up here. The volume of this total object in meters was 21.67 meters cubed.